Good morning or afternoon or whenever you're watching this. This is just a quick little reminder about some of the questions and topics on pages 4 and 5 in that Unit 10 packet. Some of these were some words that we talked about if you were in class before spring break. It may have been a while. And if you were absent or a B-day, we hadn't really even had a chance to talk. So let's kind of remind yourself of some of the things you knew. So polar, let's kind of start with that. Polar is an uneven, remember polar means an uneven electron distribution. That's why water is very, very polar, because it has those lone pair electrons. That bent molecule, these lone pair electrons, means it's really, really polar. It's so polar, think of it like a magnet. And so that magnet is going to be attracted to other magnet. So polar is uneven. I don't know why I didn't write this down here. Uneven. So nonpolar then must mean it's an even distribution. Now, I'm not going to say that you're going to have to draw all these. That's what we had to do way back before Christmas. But there are a couple you should just kind of know are nonpolar. And I told you this, but you've slept a few. Hydrocarbons, so compounds with only hydrogens and carbons, they're called hydrocarbons, are always nonpolar. Diatomics, your 7 diatomics are always nonpolar. You should know, and remember that's your 7. And even you should just know water's polar, without a doubt. Water polar, water polar. So that like dissolves like. What is the like that we're talking about? It's the polarity. So that means polar will dissolve other polar molecules. Nonpolar will dissolve nonpolar molecules. So that's why if you've ever mixed oil, oil is just a lot of carbons and hydrogens. I am totally making this up. Don't Google it. So that this is oil and this is water, I would ask, do these two things mix? And you would say no, because oil is non-polar, water is polar. Those two are not attracted to each other, so therefore it's not going to have a mix. That's why when you put a mixture of oil and water together, they do not mix. They do not have the same polarity. That's why, look at the joke on page 3. It was so good it made it into the packet. That is one of my favorites. Okay, so water is so polar, it's almost ionic, and that is why water will dissolve a lot of ionic type compounds. So let's review ourselves. What makes ionic compounds? And I'm talking about compounds here. Remember, that's a metal and a non-metal. And then molecular compounds are non-metals only. So when it's a molecular compound, then you look and going, okay, is it a polar or non-polar molecular compound? If it's an ionic compound, for right now, you can say, yes, water should dissolve it. The next podcast is actually going to talk about how do we know, do all ionic compounds dissolve in water or not? So then we have this word electrolytes. An electrolyte, I think most of you probably heard it if on TV or commercials and probably have consumed some. Yep, Gatorade. Electrolytes means it contains, if you read labels, and that's a good thing to do, find a bottle, read the label, it's going to have some kind of an ionic compound in there because your body needs the electrolytes. So this contains, here's the key word, ions, which are charged. Remember, an ion is a charged particle. So if you look, there's sodium and potassium ions, not solid sodium and potassium. That could get exciting. And those charged particles help your brain, your nerves, because they fire on synapses. And the way those brain impulses are traveled are through the ions that you have in your body. So that's why if you're dehydrated or if you've been sick, you need to drink something that has those ions so that you can kind of recharge your body so that you can be firing on all cylinders in an essence. And that's why if you've been sick, and you've really been worked out hard and you feel fuzzy brain and you feel kind of sluggish because you don't have, your system cannot transfer those impulses like it wants to do because your lack of the ions. So if then an ionic compound, I'm saying, so water is so polar that it can dissolve other polar compounds, but we're also for now saying it can also dissolve ionic compounds. So what makes an electrolyte then? What kind of compound would be an electrolyte? Here's your clue. And think of an electrolyte, think of the word, break it down. Electrolyte sounds like electricity. Think of a battery. If you have to know which way to put that battery, you have a positive and a minus. So that means we need to have those positive and minus. There it goes. That's the ionic. So therefore, ionic compounds or some way to create the ions need to be in that compound. So therefore, ionic compounds that are dissolved, because those ions have to be able to move and to be free, so they're melted ionic compounds, and we talked about that with the properties of ionic compounds, so they conduct electricity. If something conducts electricity, it is an electrolyte. Okay, so that should probably help you a little bit on those pages 4 and 5, and then there will be a separate podcast for page 6. I hope to be seeing you, quote, I'm doing air quotes, soon, and all take care.